Another trick that I might use is to solve this trigonometric equation by squaring both sides. So I'll use this technique if I don't see any of the other identities that work, or if if I don't see a way that I can switch like sine into cosine or whatever it happens to be. So if you notice here, I've got both a sine and a cosine. So what I'm going to do is I'm going to square both sides. Now be careful, because watch what happens. Let's say, so as a side note, let's say x was equal to 2. Okay, and now I squared both sides. I would get x squared is equal to 4. But what are the two values? What are the values here that make this true? Well, x could be 2 or x could be negative 2. So even though we started out with x just being 2, by squaring both sides we ended up with an additional solution that doesn't actually belong there. So when we square both sides, what we do is we take the values and we plug them back in to make sure that they actually work, because you can end up with these solutions that aren't true. So be careful when you square both sides. So when we do this, we're going to end up with sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. And that's going to be equal to 1 squared, or 1. Now what we're going to end up doing here is we're going to combine some terms together. So I've got sine squared and cosine squared. So when I add those together, I get 1. So the left side is really 1 plus 2 sine theta cosine theta. Now if I subtract 1 from both sides, I get 2 sine theta cosine theta is equal to 0. So that means, now let's go ahead, before we do anything, what I can do is I can take both those guys, well, I can divide both sides by 2. That's really irrelevant here. So I've got sine theta times cosine theta is equal to 0. Since I've got multiplication between two things and it's equal to 0, I can use a zero product property. So that's going to give me the sine of theta is equal to 0, and the cosine theta is equal to 0. So let's see when that happens on the unit circle between 0 and 2 pi. So I'm going to start at 0 degrees. I'll start working. Now wait, before I even start, at 0 degrees the sine value is 0, or 0 radians. Okay, so my solution set for theta, the first one is 0. Now as I start going along, I'll hit here where the cosine value is 0. So we'll put in here pi over 2 is a solution. And we'll keep going, we'll get down to here. And so that's when sine is 0, which is at pi. Again, we'll keep going, we'll hit here. And their cosine is 0, so 3 pi over 2. And again, if I keep going, I'll hit up here, and that is at 2 pi. Now I should check those. So let's go ahead and check each one of those. So if I plug in, so I'm going to plug them back up into here. I'll erase this over here, so I've got some room to do that. So let's try 0. So the sine at 0 radians plus the cosine at 0 radians. Let's see if it's equal to 1. So sine at 0 is 0. Cosine at 0 is 1. And I do get 1 out. So this guy checks. Okay, let's try another one. So let's try pi over 2. So that would be the sine at pi over 2 plus the cosine at pi over 2 is supposed to equal 1. So the sine at pi over 2 is 0. The cosine at pi over 2 is 1. And that does equal 1. So that guy checks. Now we're going to start to run into some problems pretty quick here. So this sine at pi plus the cosine at pi, this is equal to 0 plus negative 1, and that is not equal to 1. So negative 1 is not equal to 1. So this guy right here is not a solution. Now think about why that happened. When I plugged it in, I got -1, and I'm supposed to get it equal to 1, but when I squared both sides, so this step right here caused this thing, which wasn't a solution, to actually look like a solution. So that's not going to work. Okay, so now let's go to the next one. So that's the sine at 3 pi over 2 plus the cosine at 3 pi over 2. We want that to equal 1. We want to see if it does equal 1. So the sine at 3 pi over 2 is -1. The cosine is 0. And again, we have got -1 is equal to +1. So that's not true. So we won't use that guy either. But since 0 degrees worked, 2 pi will also, or 0 radians worked, so will 2 pi. So our solution set for that is going to be the following. It's going to be 0. It's going to be pi over 2. And it's going to be 2 pi. So now wait, before I close it out, let's go ahead and check that on our calculator. So let's clear out what we've got. So we want the sine of x plus the cosine of x. We want to know when is it equal to a height of 1. So between 0 and 2 pi, I'm gonna go by, let's do pi over 2 to just make life a little bit easier. And now let's go between -1 and a height of 2 so that we can see what we're including. So we'll graph it out. And now if you notice, our values that work are 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, which is 2 pi. So here, here, and here.